In this video, we will see how we can implement a stack using the arrays. Uh, for this first, uh, we should know that stack can be implemented using the linked list or using the arrays. So let us see how we can implement the stacks using the arrays. So for this we will go to stack as array folder, and let us open this, and let us open all these files. So this is the class we have discussed earlier, stack ADT class, and this is our my stack class, and you can see here that it is inheriting from stack ADT class. So this is a child class of stack ADT, and as we have discussed earlier, if some class want to inherit from stack ADT class, then it must define the body of all of its functions. So this class is not only implementing the functions declared in the stack ADT class, but it also defining some its own functions. So let us see the implementation. First of all, you can see that it has some private members like maximum stack size, it is an integer value, and stack top, it will return the top of the stack, and we have a pointer variable of generic type. What does this pointer variable do? This will be used to create an array, a dynamic array. When we create an object of my stack class, we will initialize this pointer variable with an array with a mentioned stack size. So first of all, let us discuss its constructor. This is initialize stack, this is empty stack, this is full stack, this is push function, top function, pop function. All these functions have been declared as virtual functions in the stack ADT class, and this child class have implemented the all of these functions. Now here we got the constructor stack type. It receives the parameter stack size, then it checks the value of stack size. If it is an invalid value, then it simply gives an appropriate message, and it says that by default value of maximum stack size is 100. Otherwise, if the value is valid, if users passes for example 50, then it will create a stack of 50. So here this statement is basically creating the array of mentioned stack size. For example, if user mentions 50, then it will create an array of 50 elements. Similarly, if user passes here 70, then this statement will create an array of 70 elements. And it also initializes the top variable to 0. Okay, this is basically the constructor, and now this is our destructor, in which you can see that we are deleting the array dynamically, and we have a copy stack function that we have already discussed earlier in the linked list chapter, how we can receive another object of stack type and will copy all the elements from other object to our newly created object. Then we have a parameterized constructor stack type that will receive an object of another object of stack type and will copy the using the copy stack function will create a new object of stack. And then we have an equal to assignment operator or overriding function that will receive an other object of stack class and will create a new object using the copy stack function. So these are different methods how we can create new stack object, we can directly pass a size of the stack, and it will create a new stack object. Can also create an stack object by passing another object of stack class in the parameters, or using the equal to operator, assignment operator. Okay, now let us see the other functions that it has inherited from the parent class, and implemented those functions, like initialize stack. Simple. In initialize stack, we are assigning 0 to stack top variable. Then we have is empty stack. Simply we return the value of stack top. Is it equal to 0? If it is 0, then it will return true, otherwise it will return false. Then we have is full stack. It will compare the value of stack top with the maximum stack size. If they are equal, it will return true, otherwise it will return false. Then we have push. This is our main function. In push, what we do, we receive an item of the generic type, and if the stack is not full, then we place the new item on the top of the stack. And also we increment the top variable. Okay, otherwise if stack is full, then we can give this message. And then is top simply first of all checks that the value of the top of the stack should not be 0. If it is not 0, it returns the top element of the stack, its value, and if it is 0, the program terminates. Then we have pop, which simply deletes the top element of the stack. So you can see here, if first it checks that isn't the stack is empty. If it is not empty, then it simply decrements the value of top of the stack, right? Otherwise it gives a proper message. Then we have its constructors. Okay, so these are the implementations of the functions. And in the main function program, it says that you have to look at example 18.1. So we will look at this program in the next videos.